In this video, we're going to take a look at the domain and range of the secant and cosecant functions. So in our last video, we took a look at the amplitude, which is not applicable for secant and cosecant, the period, which is 2 pi over b, and then the phase shift and vertical shift, just as discussed before, are the same for sine and cosine. So if we look at the graph of our secant and cosecant functions, so for instance, here we have the graph of cosecant. Notice that if we look at the graph of cosecant, cosecant itself, the function itself for cosecant of an angle, the cosecant of an angle is 1 over the y-coordinate. And so wherever the y-coordinate equals 0, that's going to give us 1 over 0, which is a vertical asymptote. So y is going to be 0 if you look at the coordinate plane. Your y values are 0 if you're on the x-axis, so at like 0 degrees or 0 radians, and also on the negative x-axis as well, like pi or 180 degrees. And then you also have, every 180 degrees thereafter, or every 180 degrees, you just go back and forth. You flip from the positive x-axis to the negative x-axis. So you're going to get this to equal 0, y value of 0, if you have an angle of 0, or if you have an angle of 180 or pi, or even going back to the positive x-axis, 2 pi. And also in the negative direction as well. We got negative pi, negative 2 pi, negative 3 pi. So with cosecant, we're going to end up on the x-axis when y equals 0. So our domain for cosecant, wow, this is really not writing very well. Our domain going for cosecant is for cosecant of x. X cannot equal multiples of pi radians, so pi times some integer k. For secant, if we look at secant, secant is 1 over x. So that's 1 over x. Here we'd want to know where this x-coordinate equals 0. And if we look at our coordinate plane, your x-coordinate is 0, means you're on the y-axis. So you're on the positive y-axis where you got like pi over 2, and you're on the negative y-axis where you got like 3 pi over 2. And just as we saw for tangent and cotangent, for pi over 2, for secant of x, for our domain, x is not allowed to equal pi over 2, so starting on the positive y-axis, and then every 180 degrees thereafter, so every pi radians thereafter, so pi times k. So again, notice, just like with tangent and cotangent, if you got a y equals 0, that's going to be the pi times k, where you're on the x-axis. If you have x equals 0, now you're on the y-axis, and that's pi over 2 plus pi times k. For your range of secant and cosecant, really your values are going to be less than or equal to -1 or greater than or equal to +1. So you're really not going to have any, unless you have any changes to the vertical stretch or compression and any vertical shifts, you're not going to get any values for secant that are bigger than -1 but less than +1. So again, if we look at secant and cosecant, remember, is 1 over y. So we don't want our y-coordinates to be 0. That's going to happen when you're on the x-axis, so multiples of 180 or pi for vertical asymptotes. Your range, if you want a short way of saying that you are less than or equal to -1 but greater than or equal to +1, that would be absolute value. So the absolute value of y greater than or equal to 1 means we're going to have less than or equal to -1 or greater than or equal to +1. And if you're not comfortable with the absolute value inequalities, you can just always use this. It can get the job done as well. And again, for secant is 1 over x. So we don't want that denominator to equal 0. X will be 0 if you're on the y-axis, so we don't want x to be pi over 2 plus every 180 degrees or pi radians thereafter. And also there before, we can also look at negative pi over 2 and negative 3 pi over 2, etc. Notice the range for secant is the same, and the range will be impacted by vertical stretching or compressing as well as any sort of shifting up or down, because you will move your y-coordinates up or down. All right, so let's take a look at our examples from before. We looked at the amplitude, period, phase shift, and vertical shift. So if we look at the domain here, we have secant. Secant is 1 over x. So we don't want x to equal 0, which would put us on the y-axis. So this x minus pi over 4, this phase shift we have here, we want to make sure that this does not equal our pi over 2, it's on the y-axis, plus pi times k. And if we add pi over 4 to both sides, we get x is not allowed to equal pi over 2 plus pi over 4 is 3 pi over 4. So our domain is all real numbers except 3 pi over 4 and every pi radians thereafter and every pi radians there before. So like 3 pi over 4 minus pi, minus 2 pi, minus 3 pi, etc. For our range, again, we're starting with values that are less than or equal to -1 or greater than or equal to +1. So this less than or equal to -1, that actually acts as a relative maximum point, although you don't need to really worry about that right now. And this +1, it's opening upwards, it actually acts as a relative minimum. Now, any vertical stretching or compressing is going to multiply these values by that number. So here we have a 2. That's a vertical stretch. So now this new relative max becomes -2. So it moves it further away from the x-axis. This relative min becomes a +2. Again, you don't need to worry about the relative min and relative max labels. We don't have any vertical shifting, so that's it. These are our new values. So -2. It's going to be less than or equal to -2, and it's going to be greater than or equal to +2. So less than or equal to -2 is -infinity and -2. And, or actually should say or, greater than or equal to +2 is bracket 2 and infinity. Now, as far as what goes here versus what goes here, you don't have to keep track of the labels. You really just have to look at your end results and see which number's smaller. So in this case, the -2 is smaller than 2, so you want to have it less than or equal to -2 or greater than or equal to +2. So if we look at the secant graph, which looks just like the cosecant graph, as we saw, it's just shifted. If we look at our secant graph, notice there is a gap in y values between the -1 and 1, and that's always going to happen. So we don't want it to be the case where we have it going like this and then like this. We don't want any overlap here with our smiles and our frowns. So if we take a look at the graph of secant of 2 times the secant of x minus pi over 4. If we take a look at the graph of example 2a, here's what the graph looks like. So notice again, we have our y values that are -2 or lower, and we have our x values, our y values also, that are +2 and higher, but there's no values on the graph between -2 and +2. And as far as graphing this function goes, remember we can use that trick where if we actually graph 2 times the cosine of x minus pi over 4, so just replace secant with cosine, here's what we get. And notice again, wherever that cosine graph in black hits the x-axis, that's going to give us a vertical asymptote for the secant. Wherever the cosine graph has a maximum, secant's happy. It's at a maximum. It's like it's making money on the stock market. Anytime cosine has a minimum, secant's sad because it's like it's losing money on the stock market. So we can actually use the graph of 2 cosine of x minus pi over 4 to help us quickly sketch the graph of 2 secant x minus pi over 4. So all right, part B, y equals -1/3 cosecant of x plus 1. Here cosecant is 1 over y. So where is y going to equal 0? It's going to be on the x-axis. So that's 0 degrees, pi radians, 2 pi, etc. So this time we don't want x to be pi times k. So notice here with x is 0, that's on the y-axis. Pi over 2 is on the y-axis. Here with y, we don't want that to be 0. It would be 0 if it's on the x-axis. So if you want, you could put a 0 plus pi k here. You're more than welcome to do so. But this is your domain for part B. It's nice because there's no changes to the period or phase shift. So just x can't equal multiples of pi. For our range, again, we're going to look at any kind of vertical stretching or compressing. You could look at reflections as well. So we're going to start with -1 and 1. This negative out in front is going to reflect it over the x-axis. So this will become a positive 1. This will become a -1. We're still going to have -1 and 1. So the negative really isn't going to impact our range at all. But this 1/3, we're going to multiply each of these values by 1/3. And that's going to give us -1/3 and positive 1/3. So this 1/3 out in front will compress it closer to the x-axis by multiplying our y-coordinates by 1/3. We also, in this problem, happen to have a vertical shift of +1. So that's going to move each of these values up 1 unit. So we're going to add 1 to those y-coordinates of -1/3 and positive 1/3. So when we do that, what we end up with, -1/3 plus 1 is 2/3. 1/3 plus 1 is 4/3. And remember, we're going to take the smaller number and go less than or equal to that value, and take the larger number and go greater than or equal to that value. So the smaller number here is 2/3, so it's -infinity to 2/3, including the 2/3, and, or, I should say again, or 4/3 or higher. So 4/3, that's a 4, and higher. And there's our range. All right, part C, we have 1.5 cosecant 2x plus 2 pi over 3 minus 5. Cosecant, again, is 1 over y, so we don't want our values to be on the x-axis. Those are going to cause vertical asymptotes. So this time we are going to set this 2x plus 2 pi over 3 for our domain. We're going to set this to be not equal to pi times k, or pi times n if you want to use n. So this time we're going to subtract 2 pi over 3 from both sides. We've done that before. You're going to get -2 pi over 3 plus pi times k. So these are not like terms, so we can't subtract them and get something new, because this has a k and this one does not. Then either divide everything on both sides by 2 or multiply everything on both sides by a half. -2 pi over 3 times a half is -pi over 3. And then pi times k, multiply that by a half or divide it by 2. I like to put the 2 below the pi, because what this means is we're going to get a vertical asymptote at -60 degrees, and then every 90 degrees left and right of that. So at -pi over 3, and every pi over 2 to the right, and every pi over 2 after that to the left. So our domain is x cannot equal this sequence, any of the values that for integers of k. For our range, we start with, yes, this is our range. Sorry for the penmanship. We start with -1 and 1. Less than or equal to -1, greater than or equal to +1. This 1.5 that we're multiplying is going to make it -1.5 and +1.5. And then this -5 means we're going to take and subtract 5 from each of those results. So -1.5 minus 5 and +1.5 minus 5. And when we do that, we end up with -1.5 minus 5 is -6.5. 1.5 minus 5 is -4.5. And for -6.5 and -4.5, -6.5 is the smaller value. So it's -infinity to -6.5 with a bracket. And we're going to put that U symbol there. And -4.5 and above. And there's our range for part C. All right, that about does it for this video. Thanks for watching.